Okay, the value it is returning is count. So now it is return print of the number of digits, the number of digits in the number of digits, the given number are comma count. Brilliant. Okay, so we have to call this function. So digits, the case sensitive, remember that they have to be called with exact function. Digits underscore number of, let us say it is 145, has 3 digits. So whenever this function is called, it is going to go back to this one, setting count value is equal to 0, and for I in the range of n should be greater than 0, but only if n is greater than 0, then it is going to integer divide. Okay, if it divides until there are number of digits, the number is going to become 0, right? So until then it is going to repeat the count process. Okay, let us see what is the result. The result should be 3 because this is a 3 digits. The count actually returns the number of digits in this one. So let us see here. The number of digits is in the given number are 3. Brilliant. Let us give another number which has different number of digits. Digits underscore number of, let us say I have given a 5-digit number. Let us see what will happen. See here, the number of digits, the given number are 5. Very good. This concept we are using, employing, and finding out the Armstrong number. Define Armstrong number. Let us say define Armstrong number, whether the number is Armstrong or not. Let us see. N. Okay, define Armstrong number of n. Okay, so for I in the range of n, first of all you have to find the number of digits, obviously. Okay, number of digits. Okay, if the same concept we are employing, the this concept which we have used, I'm coding it again. If n is greater than 0, n is greater than 0, then n is equal to n integer division, then this will give you the number of digits count plus equal to 1. Very good. So now we have to cube the, because Armstrong number, we have to cube the digits. Okay, every digit starting from 3. So how we are going to do that? Okay, so we are going to use modulo operator to separate the digits. 153, you modulo divide this with 10. What happens? Modulo division, modulo, if you apply modulo operator, it is going to return remainder. So modulus of 10 is going to give you 3, right? Then you are applying power. How many digits are there in this number? That much power you have to apply, because this is 3-digit number. You'll apply 3, right? Then what happens? Then you have to get 5. So it's not easy to get 5. So what we'll do is, you are going to integer divide this number with 10. So when you integer divide with 10, double slash 10, what happens? It is going to be 15.3. 0.3 will be neglected and only 15 remains. Okay, then you apply modulo to this again. 15 modulo 3, 15 modulo 3, 15 modulo 10 will give you 5 because it is 1.5, and modulus will give you remainder, so 5, and this 5 has to be added to this one, 3 power 3 plus 5 power 3. Okay, so in this way you are getting flipping the digits from back to the, from units place all the way to the whatever the number is about. So the similar thing will repeat, and then again you are going to use the divided. So you have to write a for loop here, but n is destroyed, n is, what you can say, n value is disturbed because you have already divided n. So we'll assign the value of n before doing any of the operations to find out digit to another variable. Suppose that it is O is equal to n. Okay, so the value of n is assigned to O. So you can write for loop here. So we are coming back from this for loop for I in range of O, because n value is changing after you are applying this loop. By the end you complete this for loop, this one, value of n is going to be 0. Okay, again you cannot use the value of n. So you are initially you are assigning the value of n to a variable O. So for I in range of O, okay, again you have to continue this only if n is greater than 0. Okay, until there are digits. What does it mean? If n is greater than 0 means until every digit accounted for. So what you are going to do is basically you are initially modulo dividing it, modulo, sorry, so you are assigning some value to the, what you can say, remainder. Suppose that rem is equal to n modulo 10, sorry, O modulo 10, because I have to use O here. Then O should be, value should be reduced by 10. Okay. Then you have to sum the cube. In the remainder, what you have for the first iteration is the units digit after you perform modulo operator for the one time. Okay, second time there will be second digit in the remainder. So you have to assign some value, sum of the sum is equal to 0. Okay, and then assign sum is equal to, suppose that not a sum, suppose that total OT, that's better. Okay. TOT, that is also in this loop, total is equal to total plus remainder gives you the digit and should be powered. This is power operator. Okay. Double star is power, single star is multiplication. Double power, number of digits. Okay, count. If it is 153, the number of digits is 3, so the count will become cube. Okay, the 4-digit number, then total plus remainder. So this is going to continue until iterative process until n is greater than 0. When n becomes equal to 0, by the end of the third iteration, probably if it's a 3-digit number, by the end of 3 becomes 0. Okay, then you have to return the value of total. Return, we have to check whether it is Armstrong number or not. Return okay, I'll write an if statement here. If, okay, the total value equal to total value what you have got after doing this sum is equal to